So let's start some numericals where we will understand what is displacement and what is distance. In last class already we have seen basic ideas about distance and displacement. Still I am going to continue very basic part so that any basic you should not miss. Our target will be complete the numerical, whatever basic numericals I am taking in the class. After that we have to solve very high level advanced numericals. In those numericals we are going to include IIT JEE, main and advanced numericals, NEET, all the numericals, topic wise I'm talking, okay? And if there is very good Olympiad question, so that you can have complete focus on these type of questions as well, and no doubt NCERT problems as well. So if you are solving these many type of numericals on a particular topic, then believe me that topic will be amazing and you will really be very good student in that particular topic. See, I have a dream. That dream is, when I am teaching you, you should not be a very good student. No, I don't want to make you a very good student. I want to make you that you have understood this particular topic in such a way that you can teach someone. It means what? I really don't want to produce good student. I want to produce teachers. I want to produce a person who can teach everything after watching my video. Okay? And slowly with time, when your brain will become enough mature, definitely one day you will believe this, that you can teach physics. Okay? Let's start this journey with this question. Find out value of distance and displacement for the given journey. So I'm taking a question here in this. Suppose you are traveling like this and like this and like this. We'll start with very basic logic. Suppose this is 1 meter, this is 4 meter, and this is 2 meter. Okay, so suppose this is point A, this is point B, this is point C, and this is point D. So for the complete journey, we need to find out what is our distance and what is our displacement. So many of you may have got the answer immediately, that you will say, sir, distance is nothing but 1 plus 4 plus 2, and displacement is nothing but 5. Okay, many of you may have given the right answer. Let's understand how to solve this problem. So see guys, which answer is correct, which answer is not correct, let's understand, and how will you think about this. So if you are behind calculation of distance, then distance is the real path, original path. So when you are coming from A, you will reach to B. So you will travel 1 meter. After that, when you are taking turn here, after that you are going to C. So you are traveling 4 meter. And then again you will take turn, you will reach, and you will reach to D, correct? So 2 meter. So this is going to be 4 and plus 1, 5 and 2, 7 meter, correct? Now when you talk about displacement, so displacement is going to be that value which will start from A and which will end to the entirely D. For example, start from A and go to D like this. So you need to calculate this length. Okay, so if you are calculating this length, means AD, that is going to be your displacement. Okay, now how will you calculate AD? How will you calculate AD? So see here, actually if you will go with the help of geometry, like here, suppose this total is 1 meter. Now this total was 4 meter and this total is 2 meter. Okay, let's understand. Can you find out this length by using any basic geometry? No, we need some extra advanced geometry. So when I'll be teaching you mathematics, that time I will teach you how will you tackle these type of geometrical problems. So for time being, you understand this A and D length, if anyone can solve right now in this class, okay, just comment on YouTube like you are able to find the answer. but condition is you must be in 11th class or you should be preparing for 11th and 12th subject. Okay, you should not be a teacher watching my video. Okay, so comment me A to B, what is the length, right? And really, if you'll be giving right answer, I'll be very happy. Now let's target some another questions. You are starting from a point, you are going in this direction, and then you are making a curve like this, and you are going in this direction. Suppose this is 1 meter, and here you have made a circular path, so this will be having a radius. Suppose that radius is 2 meter, and then further you are traveling 1 meter. Okay, so see, in this case, if you want to find out displacement, sorry, let's find out distance first. If you want to find out distance, so see, how will you tackle distance? Very easy, original path. So now here some students may do mistake. What is meaning of original path? You have to walk on this, you take your bike or your car, or you come on this track, then you have to burn your fuel, you have to burn your petrol or diesel, it depends what kind of car you have. Okay, let me know what is your favorite car or favorite bike in the comment box, so that class can be interactive every day. So you go for distance. So distance is nothing but, first you travel 1 meter, after that this is your semicircular path. Now I am saying semicircle. Semicircle means half circle, like you have complete circle, in that you cut from here and here, so this portion will become semicircle and this portion will become semicircle. So in case of semicircle, your distance is going to be 2 pi r. So 2 pi r, this is the distance of total circle, correct? This is known as circumference. What is circumference? When you start from a point and you cover the complete circle, then this original length is known as circumference. Okay, circumference, you understood? So see, there is a technical word called perimeter. Perimeter means length of original path, that is called perimeter, the entire outer length. In case of circle, this perimeter itself is known as circumference. Okay, so the circumference length used to be 2 pi r. So this 2 pi r is for the complete circle, but I have done half circle, so I will divide this answer by 2. So this 2 and this 2 will get cancelled, so I'll be remaining with pi r. Okay, so 1 meter is here, and then pi r distance is this much. Done. Now you are remaining with 1 more meter, so you just add 1 meter. What is r here? R is the radius of the circle, so that is given as 2 meter. Okay, now it became 1 plus, what is pi value? You can say 3.1 into, just put 2 here, you can say this one is here. This total will give you 6.2. So 1 plus 6.2 plus 1. This total is going to give you 8.2. So 8.2 meter is going to be your distance. Distance means complete distance. Now we'll go for displacement. So displacement, I hope you will be giving right answer, sir. Displacement will be, you may be giving, sir, displacement will be 6. Let's understand how many of you are giving displacement will be 6. Pause this video, think on this. Now see my solution. Start from here, go here. So this is 1 meter. Now come and go here, and then go here, because see, this will also be a radius, this will also be a radius, because it is semicircle, so everywhere radius length will be same, correct? So this will also be 2 meter, this will also be 2 meter, and this is already 2 meter. Sorry, let me check, it is, no, it is 1 meter. So 1 meter and 1 meter. So this is 1 meter. So this 1 meter, this 2 meter, this 2 meter, you have to think for the shortest distance. What is shortest distance? Shortest distance I have explained in the last class, right? The straight line distance, shortest distance, means you have to start from here and you have just connect this direct. So that length means nothing but 1 meter, means this part over, then plus 2 meter means this part over, and then plus further 2 meter, this part over, and then 1 meter, this part over. I hope it's very clear. So total is going to be 2 plus 2 plus 2, so 6 meter displacement over. Let's understand one more problem. Suppose you have You started from A, you are going to B, and you are traveling 2 meter. You are going to C, you are further traveling 2 meter. I mean, this is not here, it should be here. Then you are further traveling 2 meter, you are reaching to point D, and then you are further traveling and reaching to point A again. It means you started from A and you came back to A. In this journey, you have to find out what is your distance and what is your displacement. So distance means original path. Original path length is very clear. A to B 2 meter plus B to C again 2 meter plus C to D again 2 meter and D to A again 2 meter. So total is going to be 8 meter, right? But what about displacement? So displacement, don't you think it is going to be 0? Yes, because you started from A and you finally are at A. So your initial position and final position, they are same. It means what? You cannot draw any straight line because you are at the same point. A is also here, this A is also here. Okay, if A is here and one point is here, then only you can draw a straight line. So you cannot draw a straight line because your displacement is 0. So you will say your displacement is equal to 0. I hope it's very clear. Now let's solve one more problem. Because see guys, actually in this course I will teach you everything. Everything means your 9th class whatever preparation you have not done, any kind of foundation you have not done, don't worry. This is best physics ever. You are going to complete everything whatever you should be knowing about 9th, 10th, 11th, 12th physics, so that you can qualify all the entrance exams. That is my target. So now you go for one more type of problem. You started from point A and you traveled a circular distance, okay, and you reached to the same point A again. So in this case, if you want to find out distance, so distance is nothing but original length, correct? So original length means that is perimeter of the circle. Perimeter of the circle is nothing but 2 pi r, that is known as circumference, correct? So distance is going to be 2 pi r. So if I am giving you radius as 2 meter, then it is very simple. You will just put 2 into pi value 3.1 into r value again 2. So it is going to be this 2 and this 2, 4 and 3. If you multiply 12.4, this will be your answer. This will be in meter. Okay. Now what about displacement? Don't you think your displacement is going to be 0? Because your initial and final position was same. Okay, that's why. Okay, now these three examples are sufficient to understand how to know distance and how to know displacement. When we'll be solving some like main problems, there these problems, small problems will help you. So what are the main things what you should know from here? If you have a circle, then in this circle, if you start from here, if you go complete and land here again, in that case, whatever answer you are coming, whatever length, total length you are covering, that length is 2 pi r. Okay, but if you travel only half distance, started from here, landed here, then only pi r. How pi r? Because this total I am dividing by 2. Imagine someone is starting from here and traveling on a circular path, reaching only till here. It means what? This person did not complete the complete circle, I mean semicircle, and then after that this semicircle also he or she did not complete. Okay, object is starting from here and going only from here. It means it is just 1/4, correct? So if like this is 1/4, so 1/4 means the entire 2 pi r is for the complete cycle, that you divide by 4, because 4 parts, right? 4 parts, that's why I'm dividing by 4. So this is going to be pi r by 2. Why? Because this 2 and this 4 you will cancel. So this is how you will understand about this. Here itself, now you understand basic ideas about distance and displacement is clear. Now we are going to understand some more detail about motion. I have taught you just basic idea. Still some vectors and some kind of fancy tech, they are remaining. Let's understand. If you want to describe there is motion or not, like see in this motion, in this example we had motion, in this example we had motion, in this example we had motion. Okay, so if you want to say that there is motion or not, how can you say? There should be some proof that there is a motion. Okay, for example, right now suppose this is the earth. Imagine I am teaching you from this corner of the earth and you are sitting here. So this is your home, home of student, and this is home of teacher, HT. So I am sitting here in my room and you are sitting somewhere here and you are watching this video. So understand, if there is any so I can ask, we are in motion or not? My direct question is, we are in motion or not? If we are in motion, you should not change your answer, okay, after my explanation. Right now you go to comment box and you mention what was your right answer, what you thought in the very beginning. You thought motion is there, then you should, yes, in this example I thought motion is there. Okay, there's a motion. But if you are thinking, no sir, I thought there is no motion, or you may be thinking that no, there should be something else, then in according to that you mention your comment. When I will read your comment, I'll be happy that okay, students are watching my videos and they are liking my videos. Okay, so that I can feel that okay, whatever I'm doing on YouTube, it is worth, students are watching this, so I'm making this for you. Okay, let's understand. So see here, whenever you want to know that there is motion or not, so understand, there is only one thing which can help you to identify motion is there or not. There is something called frame of reference. When you talk about frame of reference, then only we can discuss motion is there or not. What is frame of reference? Okay, suppose guys, what is your height? Suppose this is you, okay, and you are saying that your height is something, just an example, you are saying your height is 5 feet. Okay, just an example, you are saying your height is 5 feet. So if I compare your height with this child, then your height is only this much extra. If I compare your height with this kind of object which is this much lengthy, then you have this much extra height. Okay, means in the first example I took this person as reference to describe how much lengthy you are. In third case, I considered this person to describe how lengthy you are. So frame of reference is actually a coordinate, means frame of reference is actually a place. What I mean? Frame of reference is actually a coordinate or a place. From there, I will judge my object. For example, imagine if a car is running in this direction. So one person is sitting in the car, another person is sitting in the car. Okay, and one person is standing on the road. When car is going, so distance between these two people is not being changed, or you said displacement between these two people is not being changed. So if I ask this person 2, this person 1, if I ask person 2 is in motion or not, so you will say, sir, your question is half. Why question is half? Question is not complete. I am simply asking person 2 is in motion or not. So you will say, sir, person 2 is in motion. Why? Because you will think, okay, person 2 is sitting in the car. No guys, whenever we are thinking motion is there or not, we should always ask the complete question. With respect to person 1, this person 2 is not in motion, but with respect to this third person 2 is in motion, because with respect to person 1, person 2 is not changing its position. So frame of reference gives you idea that with respect to frame of reference, your position is being changed or not. So frame of reference is a coordinate system which ensures that any given object is in motion or not with full stop with the help of, this is help, with the help of position change of the object, we can judge the motion with respect to frame of reference. Okay, means what? Suppose I have a tree here. Okay, this is the tree, and there is a road, and on this road a bike is going on. So imagine on this bike two students are sitting. This is student 1, this is student 2. So see here, I will ask, student 1 is in motion or not? So you will say, sir, student 1 is in motion with respect to the tree. Student 1 is not in motion with respect to student 2. Why? Because student 1 is not changing its position with respect to 2. Every time they are at same position. I mean equation 1, equation 2. See, both together they are changing the position, but with respect to each other they are not changing the position. Correct? In same way, student 2 means this guy. Same logic, same answer. This is not changing position with respect to student 1. So with respect to student 1, object 2 or student 2 is not in motion. But with respect to the tree, because when bike will go here, this position will change. Correct? So I hope you understood. Now come back to this question, what I asked. So I am sitting in my room, you are sitting in your room and watching my videos. Okay. So see here, this is, if this is hitting your heart, if this is going inside your heart and brain, then you will realize, yes, we both are not in motion with respect to each other. It means I am also not in motion with respect to you. You are also not in motion with respect to me, because you are also sitting in your room. I am also sitting in your room. Now you see, some students may be thinking that, sir, but earth is moving, correct? So sir, if earth is moving, suppose earth is moving like this, then we are moving. So understand dear, how can you be sure earth is moving? You did not see the earth, correct? But your logic is absolutely correct. Motion of earth, who can judge? You see, there is a satellite. In this satellite, one astronaut is sitting. Okay. So with respect to this astronaut, this earth is clearly moving. So with respect to this astronaut, me means your Viru sir, means me, and you are my student, but I didn't know what is your name. So it will be very good if you will mention your name on comment box, sir, I am watching your video from this state, because I don't know in which country you are watching my video, in which state you are watching my video, in which class you are. So I'll really feel glad if you will mention your, like, so that I can see, okay, this student is regularly visiting my class. Okay. So guys, understand this particular, so that if you will say that you are regularly coming to my class, in my next lecture, if I have to take an example, then I can put your name in my example. Okay. So with respect to the astronaut, we both are in motion, but with respect to each other, we are not in motion, even though earth is running, but we are not changing our position with respect to each other. I hope it's very clear. How will you judge the motion? Okay. So to judge the motion, we need to bother about frame of reference. Actually, frame of reference itself is of two types. So I hope you are clear with frame of reference. If you have any separate doubt that, sir, still, or during the lecture, if you got any doubt, you just mention in the YouTube that what doubt you have, so that I can explain you in next video that this student asked this doubt, so I'm explaining this doubt. Okay. because we don't have a separate chit chat thing. You can also ask on Instagram. Okay, Instagram account link I will put in my description box. Okay, so there you can find me on Instagram, and any video or any photo link I will put, and using that link you just visit my Instagram, and there will be discussing. You can send me screenshot or something. Whenever I'll be free, I'll be immediately replying to you. Okay, or in YouTube itself I'll mention that this student texted me on Instagram, so I am giving the solution. Okay, so now let's understand frame of reference. So frame of reference is of two types. One is inertial frame of reference, and second one, non-inertial frame of reference. What is difference? A simple difference I will tell you. See, in upcoming chapters you will come to know there is something called Newton's law of motion. Sorry. In upcoming chapters you will come to know that there is something called Newton's law of motion, and Newton's law of motion, in this topic you have three laws of motion. So there is something called first law of motion, second law of motion, and third law of motion. So trick is very simple. Non-inertial means Newton's first law will not work here. Inertial means Newton's first law will work. See, focus here. This question also they can ask in exam. First law, second law, and third law. So actually frame of reference is decided only because of your first law, Newton's first law. So you can mention very properly like this. Inertial frame of reference is that frame of reference in which Newton's first law holds good, means it is working very well. But non-inertial frame of reference, guys, you write the complete full form. Newton's first law does not hold good. Does not hold good. I hope it's very clear. Now we need some examples, like where can we apply, or like what kind of examples are frame of reference examples for inertial frame and for non-inertial frame. Now see, I will give my examples, and if you know any, then you will give your examples also. So frame of reference, like for example, you are in the bus and bus is going in this direction, and suppose you are standing here and other people are standing here. So frame of reference, like if the frame of reference is attached with you, or you can say in a bus, or this is moving, the frame of reference is moving with a constant velocity, then you will say it is reference frame of, inertial frame of reference. Or it should be attached, or it should move with constant velocity, uniform velocity along the straight path, uniform velocity along the straight path. But non-inertial frame of reference is that where your frame of reference will move, but with non-uniform velocity. Okay, let's understand this way. Frame of reference is of two types. One is inertial and one is non-inertial. So some students will be thinking inertial frame of reference means stationary frame of reference and non-inertial means moving frame of reference. No, you should not think like that. Your inertial frame can be in stationary, it can be a fixed point, or it can be a moving object also. But if frame of reference is moving, inertial frame of reference, then it should move with velocity constant. Okay, so what is the meaning of constant velocity? I have not given you idea yet about velocity. Just for time being, you understand velocity should be constant. Object can move, no problem, but velocity should be constant. If velocity is not constant and object is moving but velocity is not constant, in that case frame of reference is known as non-inertial frame of reference. Clear? Okay. So here we understood in today's class what is frame of reference, and we saw some examples of this. Now we'll understand motion in detail. Motion is happening or not, how will you judge? You will simply say frame of reference will give you idea that motion is happening or not. So before describing motion, you have to set your frame of reference. Okay, like suppose you are sitting here and your friend is sitting here, and this is a bus, and this bus is going in this direction. So you are in motion or not? So before asking the motion, you should decide your frame of reference with respect to your friend. You are in motion or not? So your friend became inertial frame. Inertial frame. Why your friend became inertial? Because it is a fixed point with you. Correct? Your friend became inertial frame because it is a fixed point with you. Okay, but suppose bus is traveling in this direction, and whatever is happening, it is happening on the earth. So here you have any satellite. In this satellite, any astronaut is there. So with respect to astronaut, you can also decide your frame of reference. Motion is there or not. But astronaut is also one type of frame of reference, but it is non-inertial frame of reference. So with respect to inertial frame of reference also, you can decide your motion. Motion can be there or motion cannot be there. With respect to non-inertial frame of reference, when you will decide the motion, definitely motion will be there, because your frame of reference will be accelerating with non-uniform velocity, means velocity will not be constant. And in future, very soon, I am about to teach you, if velocity is not constant, then there will be acceleration. So what is this acceleration word? Okay, so these things we will discuss in next video. And soon, see, small videos I am making so that you should not feel hectic. Like less than half an hour video, you can watch one video, then you can take break of 5 minutes, and then you can further watch one more video, like this. I don't believe in like hectic lengthy videos of 1 hour, half an hour, like 1 hour, 2 hour, like that. No, small videos you can keep on watching, so that it will be relaxed. Like roughly 20 minutes, these kind of videos will be sufficient. Okay, let's meet in next video.